Well, thank you very much for joining us today, Jason.
My pleasure.
So you are competing in the Small Business Plan competition here at the NewSpace conference. Tell us a little bit about what it is that you do and what presentation that you gave today.
Sabre Astronautics, we're working on the next generation of satellite control. It's called the Predictive Interactive Ground Station Interface. Affectionately, we know it as PIGGY. PIGGY is software that sits on your satellite ground station, and your operators use it to get better context of your satellites, really understand what's happening on the inside of the satellite and how it relates to everything happening on the outside. So it's a really good diagnostic tool that they could use to reduce the amount of risk that they have, extend mission life, reduce training time, all these wonderful things. You could control CubeSats with them, you could control large satellite swarms, whatever you want to do.
Is there a potential to have sensors that could detect whether or not there's a solar flare and be able to put the satellites into sleep mode or anything like that?
Yeah, and here's the thing. We're looking at this point just controlling the satellite without space sensing. So the way we have it understood now is you're going to have telemetry coming from the satellite, and you're going to have telemetry from Space Environment Center, such as the one out of Boulder, Colorado, the SEC. We have the ability to correlate those two together. So when a solar flare happens, we know what's going to happen on that satellite.
In the future, would that be able to have like a very early warning detection system, or would it be almost last minute?
Oh, that's right. Well, right now we're able to do nowcasting, right? So we're not claiming prediction yet, but the way the algorithms work, it's entirely possible. The limitation right now is the ability to predict the space weather. So if you think about space weather being a driver for a defect, you really need to be able to predict when that happens. So if you can predict that, and I really like what's happening in the space weather community these days. They're getting much, much better at it. But once that comes up, we're going to be in place right away to be able to take advantage of it.
What sort of capabilities would there be for automatic systems? Like if the sensors detect that there's some sort of problem, could the satellite automatically correct that problem, or would there need to be a human in the loop in order to fix whatever may come up?
Yeah, automation is the name of the game, actually. Right now we're looking at, or PIGGY, I mean it's a ground station software, but it's certainly viable to take PIGGY and put the algorithms on a spacecraft and control the spacecraft autonomously in exactly the way you mentioned. Furthermore, what I'm really looking forward to is, if you think about it, a spacecraft, if it understands its own environment and it's controlling itself and automatically safing based on that environment, it could also understand how it's responding in relation to a group of other satellites. So we're looking at, for the first time ever, constellation autonomy, which is really where the rubber meets the road in this type of complex system.
What kind of response did you get from the audience and the judges?
It looked pretty positive. I'm really happy with the presentation I gave. We had this boot camp like a business plan boot camp. And the guys who ran it were spot on. They worked us really hard, and I was really tired at the end. But I think the results showed. Everybody was very happy with both our presentation and the other participants as well. Really, I think this is a great conference. I've had a great time here in the competition. I think this is a sort of conference which is going to grow over time, and this is the first year where you're seeing a lot of companies get involved at the ground level, and I can't wait to see what happens next.